Hey there. So today we'll talk about containerization. We have seen what is container, what is Kubernetes, what is Docker, but today we'll see and talk about containerization. If you have not watched our previous videos of Docker, Kubernetes, of about containers or Azure or AWS, I would like you to go and watch the previous videos so that this video will be more helpful for you. Now let's learn containerization. So containers are often referred to as a lightweight, meaning they share the same machine operating system kernel and do not require the overhead of associating an operating system with each applications. That's why they are lightweight. Containers are inherently smaller in capacity than a VM and requires less startup time, allowing far more containers to run on the same compute capacity as a single VM. This drives higher, higher server efficiencies and in turn reduces server and licensing cost. So simply, if we have to say, containerization allows applications to be written once and run anywhere. This portability is important in terms of the development process and vendor compatibility. It also offers other notable benefits like fault isolation, ease of management, and security, to name a few. The abstraction from the host operating system makes more containerized application portable and able to run uniformly and consistently across any platform or cloud. Containers can be easily transported from a desktop computer to a VM or from a Linux to a Windows operating system, and they will run consistently on virtualized infrastructure or on traditional bare metal servers, either on-premise or in the cloud. This ensures that the software developers can continue using the tools and processes they are more comfortable with. Now, sometimes people are confused with VM and containerization. So, virtual machines has infrastructure on top of which it has hypervisor. But in case of containerization, it has infrastructure and then we have the host operating system, and on top of which multiple apps are deployed in a separate containers. But in case of VM, we can have multiple guest operating system. So containers are often compared to virtual machines because both technologies enable significant computing efficiencies by allowing multiple types of software to be run in a single environment. Virtualization technology allows multiple operating system and software applications to run simultaneously and share the resources of a single physical computer. For example, an IT organization can run both Windows and Linux and multiple versions of an operating system along with multiple applications on the same server. Each application and its related files, libraries, and dependencies, including a copy of the operating systems, are packaged together as a VM. With multiple VM running on a single physical machine, it is possible to achieve significant saving in capital, operational, and energy cost. Containerization, on the other hand, uses compute resources even more efficiently. A container creates a single executable package of software that bundles application code together with all of the related configuration files, libraries, and dependencies required for it to run. Unlike VMs, however, containers do not bundle in a copy of the OS. Instead, the container runtime engine is installed on the host operating system, becoming the conduit through which all the containers on the computing system shares the same OS. There are some challenges with virtualization approach, such as environmental consistency, deployment of application packages to VM. We have OS dependency, deployed apps are able to run on compatible OS only. Isolation level, unable to provide instant sandbox above OS level. Compute consumption granularity, unable to deploy multiple replicated apps and load balancer on application layer only within the single machine. And at last, patching of images in production grade environments, blue-green and canary deployments are not flexible on a cluster level and are hard to manage across multiple regions. So this is the sample architecture of how a containerized engine works, where we have only one operating system and the engine takes care of multiple apps deployed on multiple containers. So what is containerization? In reality, containerization has become a major trend in software development as an alternative or companion to virtualization. It involves encapsulating or packaging of software codes and all its dependencies so that it can run uniformly and consistently on any infrastructure. Containerization allows developers to create and deploy applications faster and more securely. With traditional methods, code is developed in a specific computing environment, which, when transferred to a new location, often results in bugs and errors. So all these things can be removed with the help of containers. So containerization eliminates this problem by bundling the application code together with the related configuration files, libraries, and dependencies required for it to run. This single package of software container is abstracted away from the host operating system, and hence it stands alone and become portable, able to run across any platform or cloud free of issues. So we have a engine or a kernel on top of which we have multiple containers. Each container can host different types of application. Someone can use Tomcat, Java, Debian, or others can use MySQL, Ubuntu, and any similar to this, other types of application can be hosted. Now, just to clarify, what is the difference between bare metal, virtualized, containerized, and containerized on virtualized? So when we say bare metal machines, it has networking, physical server, and one operating system, and a single operating system we have multiple applications deployed. In case of virtualization, we have networking, physical servers, host operating system, and on top of which we have a hypervisor. Hypervisor is important for virtualization. And on top of this, we have multiple guest operating system on which multiple apps can be deployed. So see the difference between bare metal and virtualized. This diagram is very detailed in nature and explains what is the difference between each type of machine. Now, in case of containerization, we have host operating system, on top of which we have container engine or a kernel, and on top of that we have multiple containers which runs multiple different apps. Now there is also one new concept, containerization on virtualized, where we have hypervisor on top of which we have guest operating system, and on guest operating system we can have container engine which can host multiple containers. So this is very interesting and new concept. Remember this diagram if you need to explain the difference between bare metal versus virtualized versus containerized. So here are some of the top benefits that helps in driving containerization adoption. First is the reduction of cost of infrastructure operation. There are usually many containers runs on single VM. Solution of scalability on the microservice function level, no need to scale instance of VM. Better security. Full application isolation makes it possible to set each application major processes in separate containers. Instant application of microservices via replicas and deployment sets. Flexible routing between services that are natively supported by containerized platform. Deploy anywhere, including hybrid environments as well. It is fully portable between clouds and on-premise location. It gives OS independent solution as well. They don't need an OS to run. Now it has faster deployment with hydration of new containers and termination of old containers with the same environments. It is very lightweight and fast, ready to use compute. So thank you so much for watching today's video, and if you think the videos are helpful, do like the video and subscribe to the channel.